Welcome back. This is a continuation of section 4 of chapter 1. In the last section, we talked about the phases of the moon and lunar eclipses. Solar eclipses, as you're about to find out, are quite a bit different. Now, of course, a solar eclipse is when the moon is blocking out the sun from our perspective here on the Earth. So the moon is in the middle. The moon is in the middle and can block out the sun either completely or partially, as you'll find out. Now, the only time if the moon's in the middle, that means it's between us and the sun, that's a new moon. So you can only have a solar eclipse during a new moon. Another way to think about it is, it's the moon's shadow crossing the Earth. And the question is, are you within that shadow? Now, there's a big difference here. When the Earth's shadow's on the moon, everybody gets to see it because it's this giant shadow across the moon, right? But in this case, the moon's shadow, by the time it reaches the Earth, it's just a tiny little dot in comparison to the Earth. And it's just going to cross. It's like taking a globe and taking a Sharpie and just doing a sharp line across the globe. And sorry, here, let me adjust this. You have to be within that little Sharpie line if you want to see a total solar eclipse. That's what makes it special. And it is special. Okay, of course, we had one last year in 2017, right across the United States. I believe it came into Oregon or Washington State, and then crossed out in South Carolina, if I remember right. I know it crossed through my hometown in Southern Illinois, and people were excited there. My parents could walk out just on their porch and see a total solar eclipse. And one of the things that makes it special, it really does get dark. You can actually see stars in the daytime. You can see bright planets and things in the daytime. Just amazing. There's a temperature drop of like 15 degrees sometimes. I still have yet to see one. Unfortunately, I could not travel. It was the first day of school, and I just couldn't. I didn't want to leave my students there on the first day. It was too important to get off to a good start. So, as I'll show you in just a minute. Another difference is the time. You had 100 minutes to see a lunar eclipse. You've only got a few minutes to see a solar eclipse. Just to give you an example, next year in 2019, the solar eclipse will be in Chile. And I think it's going to last like 2 minutes. So 7 minutes is the maximum, the absolute maximum for a solar eclipse. So make sure you get outside if you're ever in that location. It's not a good time to go take a snack break or something. You better make sure you're out there checking it out. And one of the amazing things during a total solar eclipse, is seeing the sun's atmosphere, what we call the corona. Now, the corona is out every day. It's there. But the main part of the sun is so bright that you can't see the sun's atmosphere. And so that's why it gets outshone every day, except during a total eclipse. And then you see it there, this ghostly crown around the sun. That's what the word corona means, crown, the sun's crown. All right, so let's take a look at where you'd have to be to see some various eclipses. I just mentioned the ones here, August 21st, 2017, there it was, crossing the United States, the Great American Eclipse, some people called it. You notice there are red lines and blue. I'll explain the difference in just a minute, but the red are the total eclipses. The red are... excuse me, I think I said the red are the total eclipses, and the blue are annular eclipses. So you see, I just want to point this out. I was just in Chile. Look at this. In 2019, Chile has one, and in 2020, they're going to have another one. And they're very excited, I can tell you, about that, as well as Argentina and some little piece of Brazil there, looks like. All right. 2009, I remember that one. So many people. Can you imagine how many people saw that? It went through India and China in 2009. When I first started teaching, there was one that was actually very close to both London and Paris that millions of people got to see. All right. So you notice that on average, just about every year, you can go somewhere on the Earth and see a total eclipse, a little over a year. So they have cruises that go out in the middle of the ocean to see eclipses and things like that. You can always go see one if you really want to be an eclipse chaser. Yes, there are eclipse chasers. Now, sometimes you can be in a position where you don't see the total eclipse. Here's one from 2007. But last year, since I didn't travel up to South Carolina, I decided I'd rather see the partial eclipse with my students on day one of school rather than travel and see, kind of be selfish and want to see the total eclipse for myself. I'm going to catch the next one. The next one in the United States, let me think, it's 2023, I believe, 2023 or 2022. I think 2023 in the spring, and I'm definitely going to go see that no matter what. So here we were, the first day of school, right after school. We kind of ran across the street there to a park, and I have some of my personal friends there in the picture, and some of my brand new students that were going to be some of my favorites there. I see Connor and Joe, my son's there, and just anyway, it was really neat. And here's what we saw. That's actually a picture I took that day there. Now I had a yellow filter to make it look more sun-like, but that's how much it covered the sun. That was pretty close to the maximum, I think, here in South Florida is when I got that picture there of the coverage. And of course, we had our safety glasses on, never stare at the sun under any circumstance. And so we had a special solar filter for the telescope, and there was Miss Rosa and her daughters checking it out. All right. But let's get to some total eclipses, which are just amazing, as you see in some of the pictures here. There's one in Austria, just a beautiful picture. Now, when the moon is moving along, and the sun first starts to peek out, you can have an effect called the diamond ring. Let me go back a slide or two. That's the diamond ring down here at the bottom right there. Isn't that cool? Just when it first starts to peek out. So if you ever get the chance to see one, that's what that's called at that point. And by the way, during the total eclipse, you don't have to have safety glasses on. It's the one time you can look at the sun without them. So when it is total, take your glasses off and check it out. But as soon as you see the diamond ring, now it's time to get your solar filter glasses back on. All right. Isn't that cool? That's the sun setting over the Andes Mountains. I think this was taken in Bolivia. Beautiful, amazing. Easter Island. That'd be an amazing place. Can you imagine? And just imagine what ancient people thought. We're going to do a chapter on the history of astronomy. Just imagine what they thought. When the sun would get blocked out in the middle of the daytime, it would turn dark, and the temperature, they had to just totally freak out. There's a great scene in a movie called Apocalypto that does a good job kind of showing that fear of the people. Now, if you were in a place where you're seeing a total eclipse, you are in the darkest part of the moon's shadow, which is called the umbra. And if you are seeing a partial eclipse like we did here last year, you were in the penumbra. Umbra and penumbra. So that's the lighter part of the shadow, and you're seeing a partial eclipse. Now, a total eclipse is an amazing, amazing thing. Here's why. There's no reason that our sun and our moon are the same size in the sky. That's a truly amazing coincidence. It hasn't always been that way, and it won't always be that way. But right now, at this point in the history of the Earth, okay, it turns out that the reason they're the same size, the sun is much, 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 much larger than the moon, but it's also much, much farther away. And it turns out that the sun is about 400 times wider in diameter than the moon, but also, just amazingly, about 400 times farther away, and that makes them the same apparent size. It's just crazy. It's a crazy coincidence. And even now, the moon sometimes doesn't get the job done. Why? Because it has an elliptical orbit. It's not a circle. It's an ellipse, so it's slightly closer at points in its orbit and slightly farther. So if the sun, earth, and moon are all lined up, or in this case, the sun, should say it properly at least, the sun, moon, earth are lined up, then the question is, well, how far is the moon from the Earth? Okay, so if the moon is at one of its farther points called apogee, it's not big enough in the sky to get the job done. It doesn't quite completely cover the sun, and you have what's called an annular eclipse. And right now in history, about half of the time it gets the job done, and about half the time it doesn't. By the way, when it's closest, it's at its perigee. So you want the moon, the sun, moon, Earth lined up, and you want the moon at perigee to get that total eclipse. Now, it seems like we'd have eclipses all the time. Seems like we'd have twice a month. We should have a lunar eclipse every month and a solar eclipse every month. But we don't. Instead, there's some type of eclipse, either one, every 7 to 9 months. Why are they not as frequent? Well, this gets kind of interesting here. It turns out they would be frequent. We would have 2 eclipses a month, a lunar and a solar, except the moon's orbit around the Earth is tilted by 5 degrees compared to the Earth's orbit around the sun. So you have one thing on a plane like this, and you have another orbit on a plane like this, and they're just slightly different. Now, where they cross is called a node. So that throws in this whole other factor. That's why most months, the sun and the moon, they just aren't quite lined up correctly. The sun, Earth, and moon. So they have to be at a node for all of this to happen. That's true for lunar eclipses and for solar eclipses. Okay, the Earth's shadow misses the moon's shadow misses the Earth. Both things happen if the moon is not at a node. You need the sun, Earth, and moon to all be on what's called the ecliptic. Yes, from an earlier lesson, the ecliptic. That's where the moon has to be. That's why it's called the ecliptic, to have an eclipse. Now, what's the difference in the sky between perigee and apogee? Well, check it out. Yeah, pretty noticeable difference there. When the moon is closer in its orbit, that's when you get a larger full moon than normal. And the largest one of the year, they started this term supermoon. I don't know where that came from. I mean, that term didn't exist when I started teaching, but they started this supermoon idea. So that's when the moon is at perigee at its largest. And you can see there at apogee is when you're going to have annular eclipses, if you have an eclipse at all. All right, so that's an annular eclipse. That's a really great picture there, great sequence where, hey, everything's lined up right. The moon's at a node, everything's lined up properly, and yet the moon is just a little too small in our sky to cover the sun. And this is what an eclipse might look like someday for astronauts on the moon. There was never an eclipse while astronauts were on the moon back in the 70s, but this is what it might look like, or it's what it could look like now from a satellite or something. But someday colonists on the moon, I guess, will have an eclipse like that, a solar eclipse that's caused by the Earth. Pretty cool stuff.